Hello everyone. So today we are going to discuss about the session handling in the PAN OS, right? So what is the session? So basically, session is the state of your connection which firewall is going to maintain, right? Why it does that? So that it can apply policies. It can do the sanity checks, right? So before establishing a session on the firewall, your firewall is going to perform certain tasks which I have already explained you inside the life of a packet, where we have shown the slow path processing, right? So there we do TCP sanity checks, we do zone protection check, we do security processing, policy check, right? We evaluate your NAT, and we do the forwarding lookup to define your to get your destination zone details and egress interface details. So after parsing all these steps in the slow path, then firewall is going to create the session for you from the free pool if all the checks are passed, right? So it's like this. Let's say you have a firewall here. This is your firewall, okay, and you have a machine here. Now this machine would like to communicate with the Facebook server. Facebook.com. So what you will do, you will open up the Chrome browser in this machine and you will right away type https facebook.com, right? So what happens in the background? First, your machine is going to do DNS lookup. Now what is DNS lookup? It is going to resolve this particular domain name into the IP address, right? So that once it has the IP address, it can initiate the TCP connection request, right? So it raises the DNS lookup, it raises the DNS query to the DNS server, whatever you have configured on the adapter, right? So it reaches out to that particular DNS. DNS is going to provide you the IP address of this particular domain, right? You can have your local DNS, you can have your public DNS. Once you get the IP, your machine is going to establish the TCP connection with this particular destination server. So now what happens? Your machine is going to send the TCP SYN packet, right? So how do we establish the TCP connection? With the help of TCP three-way handshake. So first we send SYN. Now this SYN will come to the firewall, okay, before it can reach to Facebook. Now firewall will try to extract few information from this SYN packet so that it can use it to establish a session, right? So it's like a ledger where you are just taking care of your tradings, right? So whatever connection is passing through the firewall is taking log of each and every connection. It is maintaining the state of those connections. What is the state? Whether it is active, it is discard, it is closing, opening, right? So firewall is going to maintain the state for that particular connection. So whenever your SYN comes to the firewall, now what PAN OS is going to do, right? So PAN OS is going to extract the 6 tuples. Now what are those 6 tuples? Your source and destination addresses, your source and destination ports, your protocol, and your ingress zone. Why do I need this, right? To derive flow key. Now what is this flow key? Session can be identified on the session lookup on the basis of flow key, right? Each session has 2 flow keys. One is for client to server flow, another one is for server to client flow, right? So what do we do? When you have received this TCP SYN on the firewall, PAN OS is going to extract this particular information, source and destination IP. Let's say your machine IP is 10.1.1.1, right? And this destination server is 8.8.8.8. So now in my tuple, I'm going to extract this, right? This is my destination. Then source and destination port. So since I am initiating the connection, my source would be random and my destination, since it is HTTPS, it will be 443. Now protocol, so this is TCP connection, so protocol number would be 6. Ingress zone, let's say this zone is trust, so my ingress zone is trust. Now what PAN-OS is going to do, PAN-OS is going to take the hash of this entire information and it is going to derive the flow key for client to server flow, right? So to constitute a session, we need two flows. One is client to server, another one is server to client. Now two flows are there to establish your session, right? So that we can identify the packets coming from the client towards the server, and we can identify the packets coming from the server towards the client, right? So now this is according to the firewall. Now how we are defining who is the client and who is the server? So anybody who is initiating the connection for the first time from firewall perspective would be client, and anybody who is responding for that particular first packet from firewall perspective would become server. Okay, so who is initiating the connection here? This particular machine is initiating the connection here, so this will become client. So whatever packets this machine is going to send it towards the Facebook, those will come under client to server flow, and whatever packet Facebook is going to send it back to this particular machine, those will come under server to client flow. Okay, so let me just show you how Palo Alto firewalls are going to maintain the session tables, and how you can see it, and why it is very important in the stateful firewalls. So this is the lab we are going to use. Okay, so you can see that this is my website. This website is hosted on this particular Linux server, right? And you can see it is behind the Palo Alto firewalls. So what I'm gonna do, I'm gonna refresh my browser. So I have accessed this web page. Okay, let me do one thing. Let me access this website again, right? So now I have tried to open up this website which is hosted behind the Palo Alto firewall, right? So what I'm doing, I'm coming from internet link. I have reached to the Palo Alto, then Palo Alto has forwarded my request to this particular Linux server, right? And then this Linux server has responded back to me, and that is the reason I'm able to open up this particular website. So show session all, right? So right now you can see it is undecided. My application is undecided because initially firewall is not able to identify your application. Later on it will become web browsing, right? But I can see that this is my source IP, right? And this is the destination IP I have received from the DNS, my local DNS, and this is the translated IP on which your Palo Alto is doing the destination NAT, right? Now all of this information is very crucial, because when you are doing the packet based troubleshooting, let's say customer is saying that I'm unable to open up this particular website or this particular portal, and you need to do the troubleshooting. For that you need to understand the packet flow, how it is coming to the firewall, on which particular interface it is coming on, right? And from which interface it is going out, right? And whether we are able to establish the session or not. If we are able to establish the session, it means that we are able to successfully parse the slow path stage, and we have entered into the fast path, right? If you are not able to see any session, it means that your packet is itself dropping inside slow path, and then we need to focus on the slow path troubleshooting. So to get more details about this session, what I would do, I will select this particular session ID, and I will type show session ID and this particular ID, right? And if I'm going to hit enter, it will give me all the details regarding this particular session, right? So you can see it is starting from client to flow, client to server, right? So I told you earlier as well that there are two flows in a session. So client to server. So who initiated the connection? I initiated. This is the public IP of me right now, right? Destination. Now destination is this. Who gave me this particular IP? the DNS. Now don't get confused that how this private IP is routable over the internet, because I'm connected to my cloud right now, right? It is my private infrastructure, and that is the reason I'm able to visit the private IP, right? So it is going over the VPN. So now you can see my source IP is this, my destination IP is this, protocol number 6, right? You can see source port, you can see destination port, you can see state of the session, that is init, initializing, type flow, source user unknown, destination user unknown. So what are the 6 tuple? Source and destination IP, protocol, source port, destination port, and your ingress zone. So what is the ingress zone? I'm coming from Untrust, I'm coming from internet, right? Now what I'm gonna do, I'm gonna take the hash of this information and I will generate one hash key that will be called as flow key for this particular client to server flow, and it will be inserted into my database of the Palo Alto firewall, right? Now why I'm doing that? Because I can identify further packets, or you can say subsequent packets, which are coming from this client towards this server, so that during my flow lookup I will not send them inside this slow path, I will right away forward them inside the fast path to save my CPU cycles, right? Similarly, you will see that we have a server to client flow, and you can see now the source is this particular IP. So you can see that, you know, here I was having destination IP as this, but now it is showing a different IP in the source. It should be this, right? But it is showing this. It means that your Palo Alto firewall is doing the destination translation, right? So it is doing the destination translation. So initially it has received the request for this, but your Palo Alto firewall has done the translation, and it has, you know, untranslated the packet to this particular real IP. So this is the real IP, your real IP of your server, right? And you will see that destination will remain same, which is my particular public IP, and your ingress is trust, protocol number 6, source port now become AD, and destination port will become whatever was the source port here, right? So it is just that for returning traffic, the values get swapped. Okay, now let's dig let's go in detail about session. So start time, you can see the time, this was the time when it started. You can see timeout value is 15 seconds. So we have default timeout values for sessions, right? So it depends upon the protocol, right? We will discuss this later on. Why do we have that? Because this particular session thing is limited on the firewall. This particular resource is available in limited quantity on the firewall. Let's say for VM100 it's 2,56,000. So if your firewall capacity is 2,56,000, it means that it can only handle 2,56,000 connections simultaneously. If one more connection will come above 2,56,000, it will drop it. So you will see that that particular new user won't be able to visit internet or something like that. Now you can see this 2,56,000 doesn't mean that you would need 2,56,000 machines to generate that particular number. It can be single machine as well. Just think of, you have a very good server and there you have opened up the 2,56,000 browser windows, right? So right away that particular machine will exhaust the limit on the firewall. So when you hit limit of the session, then you need to upgrade your box because your capacity is higher and your firewall is not capable to process your current load, right, in your network. You can see total byte count from client to server, how many packets we have sent so far. So 372 bytes. How many packet we have received so far? 258 bytes, right? And then how many of them were layer 7 packet? So 6 packets, how many for client to server, similarly for server to client. Then in which virtual system this session is established, right? So it is in vSys 1. Application, whether I'm able to identify the application. No, it is incomplete right now, right? So don't worry, we will see all of this in detail in coming lectures when I'm going to show you the actual debugs of the packet processing by the PAN-OS. There I'll show you each and everything whatever we have discussed in the life of a packet, how firewall really does packet processing, right? That is your DP-CPU, how it is going to do the processing. Now rule, which security rule has allowed this particular session? So you can see website access. So this rule has been created by the administrator to allow the communication. Service timeout override false. Session to be logged at the end, yes. So when this session will be deleted from the session table, I need to log this session so that I can go to traffic logs and I can see whether I was able to establish a session or not, right? It comes handy for monitoring purposes and to do troubleshooting. Similarly, session in session ager false. Now what is this ager process? So since I told you that this limit is limited, right? The session limit is quite limited. I mean, you can have you can have only 256,000 sessions in VM100. So to optimize the firewall overall performance, we have a ager process. Now this ager process kicks in when you have hit the utilization of 80% of your session table, right? If you have hit the 80%, it means now this ager process will try to kill the ideal sessions as soon as possible, because the default timeout for TCP connection is 3600 seconds, right? So our TCP session can be there in the firewall for 1 hour as ideal, right? So we need to have a mechanism to you can say increase the speed to kick these ideal sessions so that we can reserve our session pool for other legitimate traffic. Session updated by HA peer false. Address port translation. So this is your NAT. Yes, we are doing NAT and it is destination translation. So in NAT we have two types of translation, source translation and destination translation, or you can have both in a single statement, source and destination both are getting translated. NAT rule. So this is your NAT rule, website access, and it has been configured inside vSys 1. Then you can see layer 7 processing enabled. Yes, it is enabled. So layer 7 processing means your HTTP header processing is enabled or not. So what is layer 7? So your vulnerability profile, your antivirus profile, your URL filtering profile, these profiles works at layer 7, right? Because this is the next generation firewall and it has capability to do the layer 7 processing as well. Then URL filtering enabled. Yes, URL filtering is enabled. Now checking more stuff. So URL category. Right now Polo is not aware of this category, right? So it is showing any. If it would have been any known website like Facebook, it should have shown you social networking here, right? Since this is my custom application, so it is saying any. Session via SYN cookies false. Session terminated on host false. Session traverses tunnel false. Session terminate tunnel false. Captive portal session false. Now ingress interface, on which particular interface this packet has landed. So I have initiated it from the outside. So this is my internet facing interface. And egress interface. So this is the interface through which my first packet is leaving, right? So basically this information tells you about client to server flow, right? It will always tell you about the connection details regarding the client who initiated the connection. So this particular packet first landed on this and then left through this particular interface, and then we have received the same SYN plus acknowledgement packet on this interface, and then it left it by using this, right? So with the help of this session with the help of this session, your firewall can also trace asymmetric routing, right? That is the beauty of the firewall. So let's say your packet has first packet. Oh, let me take help of the whiteboard to explain. This is your firewall. You have Ethernet 1 by 2. You have Ethernet 1 by 1. You have Ethernet 1 by 3. Similarly, you have Ethernet 1 by 4. Now you have one router here, you have another router here, right? And this is your LAN infrastructure. LAN, or you can say DMZ, right? Whatever it is. So let's say somebody sitting over the internet, let's say it's me, and I'm trying to access particular resource which is there inside this DMZ. I'm trying to access this particular server, right? So I have initiated the request. It has landed on this particular interface. Now firewall has done the destination translation, and firewall comes to know that this would be my egress interface to reach this server. Now firewall has forwarded the packet, the SYN request, towards this particular router, then router has forwarded to this particular server. Now let's say this server is responding back, and due to asymmetric routing in your environment, this packet has landed on the router 2. And now router 2 has forwarded this particular packet to this firewall, because it was having route that if this is default route, that whatever is coming, I need to forward it to my next hop, right? Now we have received the SYN plus acknowledgement packet on a different interface. Firewall has sent the SYN packet from this interface, and now we have received the SYN plus acknowledgement on this interface. Since it is a stateful firewall, it means it was maintaining the state of the session. Firewall was expecting SYNACK to be received here, but it has received SYNACK on this particular interface. So this is how it detects asymmetric routing. Now right away your firewall is going to drop the packet. So this user won't be able to open up the website, because there is a asymmetric routing in the customer environment, due to which the website is unavailable to this particular user. Now Palo has given you the option to support this thing, asymmetric routing, with the help of active scenario. So active scenario, we will discuss this in HA, right? If you have configured your high availability Palo Altos in active, then only you can support this asymmetric routing and your packet will not be dropped. Okay. Back to session. So session QoS rule not applicable. Tracker stage firewall. Now this is very important. This tells what was the reason to end this particular session. So the reason was TCP FIN. It means session has been closed by the server itself or client itself, right? So here you will see multiple end reasons: aged out, client reset, server reset, right? So there are multiple reasons for the session end. So this is very helpful in case of troubleshooting, when you are doing packet based troubleshooting, and let's say user is complaining that whenever I open up this particular website, my browser it just keeps on loading the web page but nothing appears, right? And when you are checking the details on the firewall, you can see that either the server is sending the reset or client is resetting the connection, right? And again this is happening, and that is the reason user is not able to open up the website, right? So then you can start your troubleshooting in that particular direction. that what could be the problem. Then you can take the Wireshark captures. I mean, you can take the packet captures, you can do the analysis in the Wireshark, and you will come to know whether the TCP handshake is failing or there is a problem in SSL handshake, right? Any problem in certificate chain, any problem during chain cipher spec, right? And then you can take the actions accordingly. Now moving further, so if you do show session all, you will be able to see the currently active sessions or sessions in discard state, right? So when you type this command, you will be able to see the session ID, vsys, in which virtual system this session is running, your application detail, right? So right now one IPsec tunnel is established with this particular firewall, so you will see this IPsec ESP application. Then what is the state of that? Active, type, tunnel, right? And if any flag is set, then we will highlight that particular flag here. So we will discuss that part in coming videos as well. More importantly, you will see the source IP address, source port, ingress zone, protocol, right? Then your translated IP, your port number if you are doing the port forwarding. So if you are changing the ports, you will able to see the translated port, destination IP, destination port, your egress zone, your translated IP and port, right? So right now there is no session, right? Because you can see that this session has been ended and firewall has removed it from the session table because there is a limit, right? So whenever any new packet comes on the firewall, we allocate the session from the free pool, right? So these 256,000 sessions are there in my free pool. Now what is free pool? So if you heard of random access memory, right, RAM, so this session is nothing but inside RAM, right? So in your random access memory we have buffers, right? So with the help of those buffers we create a pool, right? So these 256,000 session resides inside your RAM. RAM is dynamic and it is volatile, okay? So it keeps on it's like whenever I need session, I can take it from that pool. Whenever my work is done, I will return it back to the pool, right? So you will see sessions are coming, sessions are going, sessions are coming, sessions are going, to optimize this overall PAN OS, right? I cannot have sessions ideal in my environment for longer time. What will happen? It will exhaust my resources and then other legitimate connections will drop, okay? So right now if I will run this command again, so now you can see another session has been established, right? Application is Google Quick. This is the session ID. So if you want to see details about it, you can run the command show session ID and this ID. It will give you all the details. What is the client to server flow, server to client flow, right? Then you can see source IP. So this is the Linux server which is there in my environment. So this particular Linux server has initiated the connection, right? And where it is going? It is going to this particular IP. So it must be any IP hosted over the internet, right? Because this is not the private IP, this is the public IP. This is the private IP, but when it is going over the internet, it must be changed into public IP before it can go to internet. Otherwise your ISP router is going to drop the packet. So you can see a source IP is this, source port is this, ingress zone is trust, protocol 17. Now it means it is UDP packet, okay? Now you can see translation. So 10.1.1.3. So you can say Nitin, just now you were telling us that if your IP is private, ISP will drop it. Then how your packet is going over the internet? So if my firewall is translating the packet into private IP only, it means there is another device, another layer 3 device ahead of me which is doing NAT, right? Which is translating my private IP into the public IP. So in my case, yes, there is another firewall in front of these two firewalls. So these two firewalls, if you see it, they are connected to this particular internet link. Now before sending your packet over the internet, there is another firewall in my environment which is doing the real translation. And I would say not just one, there are multiple firewalls in line, right? So there are Juniper is there, Checkpoint is there, ASA is there, FTD is there, Palo Alto is there, right? And then that particular traffic goes over the actual internet. Okay. So you can see that I'm translating your port number as well. So your source port was 54929, but when I have done the NAT, I have changed the, now this is source translation. I have changed your IP, source IP, as well as your source port. Why do I do this randomizer in the source port? Just to keep you safe, right? I would be having the details. I would be maintaining the NAT exhalates in my database, right? So this particular IP has been mapped with this particular IP in my table. This source port has been mapped with this particular source port. So for returning traffic, I'm going to unnat it back to these IPs and port, right? So I maintain the exhalate table as well. This is my destination IP. This is the destination port 443, destination zone untrust. And now you can see I'm not natting my destination. So what sort of translation I'm doing right here? Source translation. So just by looking at the session, you can figure it out whether we are doing the source translation, destination translation, or we are not performing any sort of NAT on that particular session. So if your translated IPs both for source and destination is same, whatever is coming here, then it means no NAT has been applied on that particular connection, right? So let's move forward. Another important part in session, you can run this command show session info. Now this will tell you about the details, about the resources your DP has, your target DP has, data plane CPU has, right? So this is the virtual firewall. It has only one DP, but in another hardwares like 5000, 5200, right, there we have multiple DPs. So if I talk about 5260, it has 3 DPs, right? DP0, DP1, DP2. So you can check the table utilization of each DP. So when you run this command, you will be able to see target DP, and it is DP0. By default for VM, we have only one DP, data plane, right? So it will automatically give you DP0 because virtual machine is running on a different hardware which is not prepared by the Palo Alto, right? So your VMware ESXi is running on a independent hardware. It can use Intel processor, right? It is not using Octeon chip, right? So Palo has manufactured this Octeon chip for DP, and similarly we have Liger, Tiger, Jaguar, and Ocelot for your network processing and pattern matching. So we will discuss all of this in coming lectures. Let's focus here now. So number of sessions supported. This machine can handle 256,000 sessions in single, you can say simultaneously, not single. So simultaneously this particular data plane CPU can handle 256,000 sessions. Now you would say that you were telling us that these sessions reside inside the random access memory, then why it is showing inside this particular data plane CPU, right? Each CPU has its own resources. Okay, so in Palo Alto firewall we have two planes, management plane, data plane. So management plane is like the traffic coming towards the box, to the box, which we say. So let's say if this is the PuDI session of the firewall, so this is to the box traffic, so it will go to management plane, right? Although you can configure these management services on your data plane as well, I mean you can configure these services, but it is not recommended. Why we have segregated the planes? Because we don't want that the management related traffic of the Palo Alto firewall is causing problem bandwidth issues in the data plane, or it is increasing the resources of data plane, right? Because data plane CPU utilization is very much important when we talk about the production firewalls, especially we are going to place these firewalls in the data centers, right? So I just don't want that to open up the GUI of this firewall. My traffic should go to data plane of the firewall. It should directly land on management plane, right? Similarly, number of allocated sessions. So out of this limit, how many sessions currently I have allocated? So it means this will tell you what is the session table utilization. So right now I've just allocated 2 sessions out of 2,56,000, right? So right now my firewall is least utilized. Okay. Number of active TCP session 0, UDP session 1, ICMP 0, number of active GTP session 0, HTTP 2 0, GTPU broadcast, multicast, predict sessions, SCTP, SCTP associations 0. What is my session table utilization? 0%, right? Because right now we are not utilizing the firewall. There is just one user who is working. Office is closed. Number of sessions created since boot up, right? Since this firewall is up, 1439. Packet rate, 16 packets per second are coming on this firewall. Throughput, 8 kilobits per second. New connection established rate, it's 0. It's 0 in my case. But in data center, you will see that these figures are really high. Then these are the default timeout settings which you can see here as well. So for TCP application, for TCP protocol, 3600 seconds. TCP session timeout before SYNAC received, 5 seconds. Timeout before 3-way handshake, 10 seconds. Half closed session, 120 seconds. TCP session timeout in time wait, 15 seconds. TCP session delayed acknowledgement timeout, 250 milliseconds. Then similarly we have a timeout for unverified reset. UDP it's 30, ICMP 6, SCTP default 3600. Like this you can have a look. Okay. Similarly, now comes the important part, acceleration of aging process. So I told you earlier as well, what is aging? There is a process which runs in the PAN-OS to clean up your session table. So whatever ideal sessions are there, which are just occupying your bandwidth of the session, this aging process is going to kick them off and move it back to the free pool, right? So when this process gets active, when the utilization of your session table is 80%, right? So this process gets active, and what is the scaling factor? 2x. 2x means, let's say for your TCP connection, the ideal timeout is 3600 seconds. So if my session table utilization is 80%, then what this aging process is going to do? It will reduce the 3600 seconds by 2. It is going to divide that value by 2, and it will become 1800 seconds, right? So this is how it goes. It reduces your aging time, and if no packet comes, then it is going to free up the session, move it back to the free pool. So these timeout values, they get refreshed whenever any subsequent packet comes. So if you have seen my first video as well, so I told you there as well that whenever any packet match is there to that particular session, your timeout value gets refreshed. Then session setup. So you can see there are few TCP state sanity checks. So reject non-SYN first packet. I'm going to reject it if first packet is not SYN. Hardware session offloading, true. Hardware UDP session offloading, true. Now what is offloading? Okay, we will discuss this part later on, because this will involve your network processor, Liger and Tiger. Just to increase the performance of the box, we offload certain sessions on which we have already done the layer 7 processing, and they are the encrypted sessions like SSL, and we are not doing the decryption. In that case, there is no sense to waste the CPU cycles, because we ultimately won't be able to inspect that particular traffic. Then tunnel acceleration, IPv6 firewalling, all these things, strict TCP/IP checksum is there, TCP reset sequence is there. So these things are true, and is small initial window false, right? So these are the pre-checks for my session setup. Now the another important point for troubleshooting is session behavior when resource limit is reached, right? So let's say your resource limit is 2,56,000 and you have received 3 lakhs connection simultaneously. Your firewall is handling 3 lakh. It has received the request for 3 lakh connections. So it will only process 2,56,000. Rest of the 44,000 connections will be dropped. So if you remember, when Flipkart announced the big billion days, server got crashed, right? So because all of a sudden it has received so many requests, it failed to process all of them. It went out of resources. Same thing applies here as well. Okay. Yeah. Same things you can verify in the GUI of the firewall. So if you go to Palo Alto firewall, if you log in into your firewall, you can go to monitor tab, right? And you can simply go to session browser here, right? You can click on it and it will also display all the details. So right now my IPsec tunnel is up, only one session I can see. So if I will refresh the connection here, I will be able to see another session. So you can see this session, right? Application, web browsing. You can simply click on plus and it will give you all the details, whatever you were able to identify in your CLI. Session ID, timeout, time to live. So this time to live, right now it is 10. If I will refresh, it's gone, right? Because that timeout has been reached and no further packet has been received from either from the client or from the server, because it is a static IP, a static website which I have created. So it is not letting you type anything, or neither server is asking for any information, something like that. So it is the static page. So either server has closed the connection or your connection got timeout. That is the reason we lost the entry. If I will refresh again, you will see this connection is open, timeout 15. If I will refresh, you will see it will keep on decrementing. Now it will be again 15. It should decrement. Yeah, it's gone now. Okay, so if I will again refresh, so it will send the TCP SYN, and here you would be able to see these sessions. Now again sessions are there, web browsing. So if you click on plus, you will be able to see all the details, which security rule is letting this particular connection to be established, which NAT rule is taking hit, right? What sort of URL category. So if you see, when I was able to identify the application, I was also able to identify the category. Otherwise it was any. Now session end reason, what would be the reason for my session end? TCP FIN, right? The connection has been closed either by the server or the client. Similarly, you can verify the detail in your traffic log. You can go to traffic log. So right now I have applied the filter for Facebook application. Let me remove it. Yeah. So these are the options: receive time, type, from zone, to zone, source IP, source user, source dynamic address group, destination. Yeah, these are the options on which you can apply the filter and you can search for your particular session, right? Session end reason, TCP fin. So if I scroll here, if you click on this magnifier, it will give you details: session ID, action source, from policy, this is the rule, right? Website, rule UUID, uniquely identification number, session end reason, TCP SYN, category business and economy, right? Logs forwarding to India firewall logs. This is the log forwarding profile I have configured. It is sending to Panorama. Then this is the source to client packets. This is your destination. So source IP is this, country is this, port number, zone, interface, NAT IP, NAT port. So right now we are not doing any translation, so it is same. Then you can scroll down. Similarly, you can see the details here: destination, this, country is this, port, AD, trust, interface. Now NAT, you can see that I'm untranslating it. It means this firewall is doing destination translation. I have received the packet for this. I'm translating it to this, untranslating it to this. Why it is important, right? This is very important for packet captures. So when you are doing the troubleshooting, if you don't know that whether firewall is doing the translation, either source or destination, then you won't be able to see packets in your captures, right? And you will just apply the capture and you will see nothing is matching, no packet. So you won't be able to troubleshoot the issue then. Then these are the flags: captive portal, proxy transaction, decrypted, packet capture, client to server, server to client, symmetric return, right? These are the flags. Then these are the details here. Right here you can see bytes, receive, send and all that, device ID, SD-WAN feature and all that. So this is the latest PAN-OS version, PAN-OS 10. And if you see this particular thing right here, right, so this will show you the packet capture. So this is how your packet comes on the firewall. It's all in binary information, 0 and 1, right? So there is a format in which we represent each and every information. So your Ethernet frame, so how your packet travels, you have preamble, then you have start frame delimiter, then you have your Ethernet frame, then you have your your layer 3 info, then you have your layer 4 info, then you have your actual payload, that is your layer 7, right? And then you have your CRC. So it comes in 0 and 1. So it whenever packet comes on the firewall is going to reconstruct it in the same format, right? Whatever bits it is receiving according to the standards of Ethernet frame, your layer 3 headers, IP header, your TCP header. I'm going to reconstruct the packet and then I will do my parsing. So if any packets getting dropped inside the parsing itself that I'm unable to understand, I have received the corrupted information, then you won't able to see that in your normal packet captures. You need to take your pre-parsed packet captures to see if any packet is getting dropped inside the parsing errors. Okay. What else you can see inside the sessions? Okay, another important part is your predict sessions. So let me go back to the whiteboard. So what do you understand by the predict sessions? So now to optimize this session setup process, what PAN-OS has offered you, it has offered you the liberty to predict sessions for dynamic protocols. Now what is dynamic protocols? Let's say applications like FTP, where we have random ports whenever we do data transfer. Your applications like SIP, right, your voice application, they use random ports for communication. Okay, so for these sessions, first we establish the connection and then we send the data. This is how these protocols works. For FTP, we have a control connection, and then whenever we do transfer, we open up the data channel to transfer the data. For SIP, first we have registrations, or you can say signaling, right? So first we have registration or signaling, and then we open up the RDP stream, RTP stream on random ports to send your voice, right? So for these sessions, what I do, I have a parent session, right? So what happens, few sessions you will see are there in your predict, right? So whenever your firewall identifies any protocol like FTP, SIP, right, in your environment, what firewall does, for future, it prepares itself for future. So firewall is aware that in future I might receive request for FTP data transfer or SIP RTP, because these connections are already established. Either the registration is done, or in FTP either the connection establishment has been done. Data transfer request has been requested yet, right? So firewall creates predict sessions for those dynamic connections, and whenever there is a match, now what is predict? It might be missing some sort of information, either source port was missing, either destination port was missing, some sort of information is missing. It means now firewall is trying to predict that this could be the session, and the moment it is going to receive any connection, it does a match, and if it matches to this particular prediction, then it converts it into the actual session, and that child session points to this particular parent session, right? The parent session was already there. Okay, so what is your lookup? How your session lookup is taking place? So first I will be checking your predict sessions, right? So whenever a packet has been received by the firewall in ingress stage, it is going to do a lookup inside the predict session. Then it is going to check it inside the session table. And how I'm doing this checking? With the help of the flow key. What is flow key? It is the hash of 6 tuple which you have taken. So I do the match here, then I do the match here. If no information is present either in predict or in session, then I go to slow path. If there is a session available in the predict, I will convert it into a normal session and install it inside the session table. If there is nothing, then I will check in the session table. If there is a session, I will refresh the default timeout. Okay. Now the important thing we need to discuss is session life cycle. What is this session life cycle inside the PAN OS? Okay, so session life cycle. Right, so initially what happens, let's say this is my free pool. Now all the sessions are here. Session ID 1, session ID 2, session ID 3, session ID 4, session ID 5, session ID 6, session ID 7, session ID 8, right? And this is your random access memory, which is dedicatedly allocated to that particular data plane. your DP CPU, right? So all the sessions will remain in the free pool unless otherwise it is used, right? If I have if I have received the request for session allocation, then only your PanOS is going to pick up any session from here and allocate it and install it inside the session table. Otherwise they will remain in the free pool, right? So what happens, we have a flow lookup table, right? So whenever any packet comes to the firewall, from the firewall will, extract the 6 tuple, generate the flow key, and try to do flow lookup to identify any existing session for this. If there is no session, in that case, it is going to create the session. It will route you towards the slow path processing, right? And we have already discussed it in detail in the previous lecture. If there is an existing session, then it will directly send you to the fast path processing, right? So it saves your processing time. So it, with the help of this slow path and fast path, this flow lookup, you can increase the throughput of the overall firewall, which is, required, because in the data center you would be receiving so many connections and we cannot have delay, right? So session state goes like this. So we start with init, initialization. Let me make some sort of space here again. Oh, sorry. Okay. So it goes like this. You have your free pool available here. Session ID 1, 2, 3, 4, 5, 6, 7, 8, right? So we have init. Then it goes to opening. Then it gets converted into active. Then it can be discard or closing. So discard, let's say any block rule has taken hit, right? Initially your application was not identified by the firewall, and after few packets it has identified the application as Facebook chat, and you have created a security rule where you need to block this Facebook chat. So your security rule will be evaluated again, and their firewall will be able to see that rule, and accordingly it is going to change the state of this session as discard, right? Similarly, in case of threat, if I have identified any threat in that particular connection, now discard means whatever packets are coming now, if they are going to match this particular session ID, firewall will drop those packets. Closing, I'm going to close the session. Then closed, then free, right? So how it goes, this is your pool. So this is your firewall, this is your PC, this is the server. So whenever you have initiated any request, it comes to the firewall. Now firewall is going to pick up the session, right? So firewall has done the initial parsing in the ingress stage, then it has done the flow lookup, there was nothing, and now it has routed you inside the slow path processing. All the sanity checks has been done. Now we are in a stage of session creation. So first we will take out one session ID from this pool, and its first state will be initializing, then it will become opening, and then it will become active. Now active is stable state, right? This is transition state. Similarly, this is transition. Transition means they are there in the system for just fraction of seconds, and in microseconds they will change From initialization, it will come to opening, it will become active. It will remain active until or unless firewall has detected any threat or any security rule is saying no, I need to discard all this communication. So changes the state from active to discard. So discard and active are stable state, closing, closed, again transition state, and then once it is free, it means now I'm returning back this session ID to this pool. So I have taken this session ID 1 from this pool. This is the journey of the entire session, and then I'm returning back this session ID to the pool. Why I'm doing this? If I will exhaust this pool, right, there is a limit. Let's say in our case it's 2,56,000. If my session limit has been reached, then new requests from new users cannot be processed by the firewall, and those packets will be dropped. So if you go to JOI, if you go to dashboard, you can see session count. So right now there is only one session out of 2,56,000. So you can see it here as well. And this widgets, they are customizable. I mean, you can simply select what you want to see. You can see top applications. Similarly, you can see system information, logged in admins, logs, thread logs, data field. You can customize these this entire dashboard as per your requirement. Okay. So another thing I missed out earlier. What about non-TCP UDP sessions? Now what is non-TCP UDP? Packets other than TCP and UDP protocols. So we have ICMP packet, we have GRE tunnels, right? So what will happen to these packets, right? How we are going to identify 6 tuple in this case? How we are going to generate the flow key? So for ICMP, we will be using the identification. So I'm not sure whether you have opened up the ICMP packet inside the Wireshark. There you will see the identification. And similarly for GRE, we use call ID, right? So that's it. Another important thing, you can verify the default timeout values in the GUI as well. You can go to device, you can go to session. So you need to click on setup, you need to click on session, and then you can see these session timeouts values here as well. So default 30 seconds, discard 60 seconds, discard TCP 90 seconds, discard UDP 60 seconds. So similarly, you can change it as per your as per your convenience. So what does it mean? So if any session is ideal, let's say any TCP session is ideal for 3600 seconds, after that it will be automatically moved to the free pool, right? So similarly for UDP it is just 30 seconds. So if I'm not going to receive any further packet from either from the client or the server for UDP protocol, then my session will be returned back to the pool after 30 seconds. Okay, so now similarly for the applications, you can also have a look. You can go to ACC, my bad. You can go to objects, go to your Applipedia applications. You can select the target application, let's say Facebook. So if you want to modify the timeout values for on the basis of application, right? So we have Facebook base, click on it, and here you will be able to see the timeout values. So you can customize it, right? So if you have your custom application, right, and if you know that it will put your connection on on ideal for some time, and you don't want firewall to be killing that particular session, so you can customize that. So if you have your application signatures available, then you can create your custom applications. You can upload your custom applications and you can define the timeout values. Okay. Similarly, moving forward, so from troubleshooting point of view, you can have multiple filters, because in production environment you're going to see that there are a hell lot of sessions and you need to identify your session, right? So you can apply the filters. So show session all, and then you can do question mark to see what are all the options PAN-OS is giving. Then you can select filter, and now you can do again question mark, and you can see. So whenever in your command you can see plus sign, it means this is optional. If you are going to run this command till this point, it will also run, but now these are the options, right? So you can use these options to filter out your results. So you can filter on the basis of application, count, CTD version, decrypt forward, destination port, right? All of this information is there. So whatever you needed, you can do it. So let's say I want to do filter on the basis of let's select any one of it. Application, or let's say, okay, first select application. Now if you do question mark, it will give you the option from your Applipedia. You can select the Applipedia. You can select the application from here. Since it is going to be very long, so what I'm gonna do, I'm gonna select it as web browsing, right? So web browsing, and if I hit enter, right now there is no active session for web browsing. So let me refresh my connection. Now if I will go back, if I will run this command, I will be able to identify there is a session for web browsing, and this is the ID, and then I can simply run show session ID. I will paste this ID and I will be able to get the detailed information about it. Similarly, you can apply the filter basis on destination port, right? Port AD, I want to see sessions for port AD. So you can see wherever my destination port is 80, I will get the details of those sessions. Similarly, on the basis of destination IP, so let's apply it. No active session. I'm getting the session details here. So can you tell me, when you applied the filter basis on this destination IP, why you were not able to see the session IDs? Why it has revealed you no active sessions, right? So if you remember, whenever we install the session, right, in the slow path, we just evaluate the NAT. We never apply it, right? We apply it inside the fast path. Okay, so I have created the session inside the slow path. So this information is handy with me, right? This is the translated. It is going to be translated. It is not yet translated. I have not reconstructed the packet yet. I know that this is going to be, but it is not yet happen. It will happen in fast path. So on this basis, you need to apply the filter. Then only you will be able to identify your sessions. If you will do it with the translated IPs, then you will get this. Okay. Another useful command we have, show log. This is for ended sessions. Traffic Show log traffic direction equal backward. Now this will give me the latest logs. Show tracker equal yes. So this will give you the details about the session and why they have been closed. So let's say you're doing the troubleshooting and customer is saying that user has done the testing around midnight, and right now user is not available, and you need to do the troubleshooting. You need to analyze what he has done. You need to get the detail about that particular session. How can you do it, right? So with the help of this command, you will be able to get the latest, you will get the latest information about the closed sessions. So this direction backward means you will get the latest info, latest time logs, right? Now what do you need to do? You can see this is the source rule. Action was allow, coming from untrust to trust. Session info, CTD VM token, source port, destination port, entries and TCP fin, source and destination IPs. So on this basis you can track your session, right? Because it is going to reveal hell lot of information. You can track your session. Let's say I wanna see this particular session, right? So internet access, quick protocol, it got aged out, right? It got aged out. Session reason was timeout because it has not received any subsequent packet. Similarly for this, TCP fin was the reason to close the session, right? Similarly, you can see the reason. Why it is important to track the reasons. You will come to know what happened to that particular session, right? So now you can, by looking at this aged out, you can tell the customer that your session got aged out. It means either client has not responded to server or server has not responded back, and due to default timeout, session has been terminated. Now to do more troubleshooting, ask your user to join the call so that we can apply the live captures on the firewall, and then I can analyze it inside the Wireshark what is happening. Okay. Now another important troubleshooting command is your counter command to see the details about your counter. Now what are the counters? See, counters, you can see it's a number which is there in your CPU. So whatever happens inside CPU, I increment one value for the respective counter. So I have divided my entire processing in multiple stages, right? And whenever packet enters into that particular stage, I increment the counters associated to it so that I can see how the packet processing is going on in the DP CPU, right? So when we are going to dig down into data plane troubleshooting, there I will show you everything. Now for this point of time, I would say stick to this command. So this is show global, just a minute, show counter global, filter delta yes. Okay, first I will run it without filter, show counter global. So if you're going to run it, you will see you have received hell lot of counters. There are 159 counters for this firewall. For physical, you will see 225, 300s, right? So it depends upon the platform. So if I would quickly run you through packet receive, packet sent value, it will always increase. Whatever it is currently here, it will always increase when you are going to run this command again. That is the reason it is a counter. I mean, it's a value, it's some sort of token which is counting something, right? So packet receive, this much packet has been received by the firewall. This is the rate, severity info, category packet, aspect packet processing, description packet received, right? Similarly for session, we have these counters. Session allocated. So session allocated since the boot up, session freed, right? Session installed, and session discard. So session discard by security policy check, right? Similarly, you will see session allocation failure. So you can apply the filters basis on the category as well. So let's do that. So I'm just interested to see the counters related to session. So show counter global filter category session. So it will show me all the sessions, all the counters related to session. Now another important command is, if you're going to run this command again and again, you will see this now, and by looking at the output you won't be able to understand anything. Now the best thing is use it with filter delta yes. Now what is delta? Delta represents the change, right? The change in the configuration, or you can say the difference the last time you got the output, and you know what has changed from the last time to this current position. So it is going to just represent the change. So when you will include delta, it will only show you the counters which has been modified the last time you run this command. Okay, so show counter global filter delta yes. So right now you can see only 13 counters got modified. Again 12, 11, 12, 11, 12, like this. Similarly, so these are the counters which are increasing right now, right? The more, if I will take more time, you will see more counters. Let's wait for let's do something on the firewall. Let's refresh and let's initiate some sort of connection. So you will see more counters are incrementing. Where is the terminal? Let me open up YouTube here. Okay, so now go back to the firewall and now run it. See how many counters have been altered. 62, again 48. Okay, so now specifically if you want to see whether your session counters are incrementing or not, you can do it. Filter delta yes, category session. So now it will only show you the session related counters with delta, whether they are changing or not. So you can see they are getting modified or not. So it was 543, and again when you ran this command it went to 0. It means no increment has been made. So whatever it was there. Now if I will run it again, now there is one value change. One session has been freed. I mean it has been we have sent it back to the free pool. So this comes really handy in packet based troubleshooting, when you need to identify what are all the particular counters which are getting incrementing for your packet filter. So for packet capture we also create filters, and for that particular connection you can trace what are all the counters which are getting incrementing, right? If it is related to drop, you can right away catch it. Oh, drop counter is incrementing. Let's say for any packet filter, your policy deny counter is increasing. So then you will get a direction for troubleshooting that you need to check security rule. There might be a security rule which is dropping this packet. Okay. So another important part which I would like to discuss here is the session state in numeric numbers, right? So because we are going to take the debugs, right? And there how you will identify what is the current session state, whether it is init, opening, active, discard, closing, right? Because in debugs you will only see numerical information, right? It will not be like this, that session is opening state, discard or something like that, right? So this is the mapping. numerical state and your session state. So 0, 1, 2, 3, 4, 5, 6 init, opening, active, discard, closing, closed, free. So 0 means init, 1 means opening, 2 means active, 3 means discard, closing, closed, free. So if you have taken the packet diagnostics and if you are doing the analysis, because this is the last resort of troubleshooting when you are doing the packet based troubleshooting. So troubleshooting is of 3 types: packet based, feature based, and root cause analysis. So when you are doing packet based, if you have checked everything and still you are not able to identify what is happening with the packet, right, why connections are not getting processed properly when you have configured everything, then the last resort of troubleshooting is packet diagnostics. So there you will see that, we are going to take it. There you will see one keyword like this, state 3. So what do you understand by this? It means that your session state is discard, right? 3 represents discard. If it is 2, it means your session is active. So that's it for today's lecture.